For this video, I'm going to show you how to create sequential data given a historical data set. Now, this is an example of a historical data set. So you can see that it starts from oldest to newest, but you could certainly use the premise in this video. If you have a data set from newest to oldest, you just have to reverse it first. And what we're going to do is we're going to look at the closed column here. We're going to take a specific sequence length. We're going to start with a sequence length of 3, and then we're going to generalize it, but I want to give the example for a small sequence length. Now we're going to create a data frame and call it data frame sequential. And for an example case of 3, the first row is going to be this value, this value, this value. That's going to be the sequence, and then this is going to be the prediction for that row. So this is going to be included in the row as well. And we're going to call that column Y regression. Then the next row is going to be this one, this one, this one, and then this one is the one for Y regression. And it just follows that trend, and you can see that it creates a sort of sequential pattern. For example, this might be fed into a recurrent neural network or any of those types of neural networks that take in sequential data. Now, this specific data frame here is of a stock example. And if you're interested, you can get this from Y Finance. That's a Python library that lets you import stock information from Yahoo Finance. Now, before I get to the video, anything I say in this video is not financial advice. If you do choose to make any decisions or financial decisions using the information from this video, I'm not held responsible for the outcome. For example, if you do choose to use the information from this video to feed into a neural network that's meant to predict stock prices. I'm just recording this after because I just want to add a quick note. Now, the pandas and NumPy libraries, you're going to need those. This TQDM one, all that is a progress tracker, and you can run that with for loops, for example, and that's what we're going to be running it with. It's just a way to show the progress of the for loop in like a little progress bar. You don't need that for this, for the purposes of this video. What we're going to do is we're going to look at this closed column here. So we don't care about the other columns. Let's just take the closed values, and we're going to convert it to a NumPy array by just typing in dot values. If we print this out here, along with the data frame, you can see that it's literally just a closed value column. There's nothing special about it. This is what we're going to take, and we're going to slice this so that we can get this sort of floating sequential data. The next step will be to define a sequence length, and let's just define it as 3 for now. Actually, I'll put this up here. So what I'm going to do is I'm going to show you 2 different methods to do this. One is efficient and one is inefficient. Now, the inefficient way, which I'm going to start with, is using a for loop, and every iteration we're going to add a row which corresponds to the sequence to the data frame. So you can imagine that there's going to be a lot of rows, and especially if you have a huge data set, this will take up a bit of time. The efficient way, we're going to construct each of the columns instead, and then just use a list comprehension. Actually, no, we're going to construct the columns using a list comprehension, and then we're just going to stack them together and create a data frame that way. And you'll see that the for loop for that one will only be for however many columns there are, which is sequence length plus 1. So it'll be a lot faster than the other method. Anyways, firstly, what I'm going to show you is I'm going to show you the structure of the for loop that we're going to create. I'm not going to specify the range yet, and before we construct the for loop, we're also going to need to actually construct the pandas data frame for the sequential data. We're not going to populate it yet, we're just going to construct it, and then we're going to add the columns. We're going to say the column names, and then with each iteration we're going to populate it. We'll call it df sequential, and the columns are going to be one more than the sequence length, because you have the sequence and then you have the Y regression. We're going to add a column later on for Y classification, which is going to be a classification style where it's going to be a 1 if the price has increased and a 0 if the price has decreased or stayed the same. In that way, you could use the Y regression column if you were doing a regression style neural network, and a Y classification column if you were using classification style. But let's just stick with regression for now. And we're going to use list comprehension to create the columns because it depends on the sequence length. And I'm just going to call it x0 through to x sequence length minus 1. We can specify it like this. There we go. So if sequence length is 3, then there'll be x0, x1, x2. You could call these whatever you want. Maybe xt minus 2, xt minus 1, xt minus 3 makes sense because it's really the days before, but I'm just going to stick with this. And then we're adding to that list y regression. And for now, I'm just going to print this out so you can see what it looks like. I haven't defined sequence length. Wait, what have I done? I didn't write columns. There we go. So now these are the columns, and you can see that it's not populated at all. And again, with each iteration of the for loop, we're going to populate the rows one by one. If I write close values here, and let's look at the first 10. The first slice that we want to take, which is going to be the first row, is here up to here, because we have the sequence, and then we have the y regression. What we're going to specify is we're going to specify the index start and the index end of the slice, which is going to be floating. It's going to depend on the iteration of the for loop. For example, for the first iteration, it's going to be, actually what I'm going to do is I'm going to write the line which appends the row first, because you'll see that index end has to be the end index plus 1, because when you're slicing an array, it doesn't include the end index. I'll show you what I mean. If you have, what do we have? df sequential, and we want to refer to the row that doesn't exist yet. In this case, it's going to be the row equivalent to the index for the length of the data frame. Hopefully that makes sense, but I'll write it down here. If we take the length of df sequential, and this .lock function here, .location, that's just a way to refer to a specific row. Well, we're going to use it to refer to a specific row. And this section here, what that refers to is that it refers to the row that doesn't exist yet. It refers to the very end of the data frame. For example, if you have a data frame of length 10 rows, the indices for those rows are going to be 0 through to 9. So if you're writing the length of df sequential, in this case, it'll be 10. So you're referring to the 10th index, which is the row that doesn't exist. And now, because there's 0, the first case is going to be 0. So this is going to be 0. You're referring to the 0th index, which doesn't exist. And then we're going to set that equal to close values index start through to index end. Now, index start, this is inclusive. But when you take a slice of an array, the index end is not inclusive. For example, if we're taking the second index over here, so that's 0, 1, 2, we want to write 3 here because it wouldn't include, if we wrote 2, it wouldn't include 2. That way, when we write index start, we're just going to write I. Index start will always be I because we start at 0 and then we'll go up to some value, which we'll write in a second. So just write it like that. And our index end is going to be I plus sequence length plus 1. Now what we're going to do is we're going to add the range here. We have the starting range, but we want it to go up to some value. And firstly, what we're going to need for the future anyways, is let's specify the length of closed values, which is 3303. It's the same as the number of rows in the data frame. So we could really write length of data frame, but I'll just write length of closed values. All right, let's look at the last values of closed values. So that'll be 3295 onwards. The last row of df sequential for this example here will be this here. This is going to be x0, x1, x2, and y regression. We want to put in a value here for I, which is going to be equivalent to this value. It's going to be indexed at this value. And this value here is indexed at, well, if this is indexed at 3302, because Python starts at 0, This is 3301, this is 3300, this is 3299, but we have to add +1 because the second argument here isn't included, it's not inclusive. So in this argument here, we want the number 3300, which is length of the DF, that's 3303, and then minus sequence length. That's 3, so then this will be 3300, so then I will go up to 3299 because, again, this one's not inclusive. We've got this value here, and this is going to be generalized for all cases, actually. I was just using the 3 sequence length example as a way to kind of write this out, to kind of show an intuitive way of why it is what it is. But length of the data frame, you know, that's generalized. Sequence length, that's generalized. If this was 7, then it'd also work in the same way. It'd work in the same pattern. That is essentially all we have to do for DF sequential. If we run this, then we see that we've got the outcome. And if we look at closed values, I'll start with the last 10, for example. Oh no, that's the first 10. All right, let's start with the first 10. The first row is from here through to here. The second row is from here through to here. And then it continues like that. And the last 10 values, the last row is here through to here. Yep. And then it continues like this. So we have 245.33, 251.5. Yep, so it works essentially. Now what we're going to do is we're going to add a column for Y classification. Now Y regression, that's just going to be the price for the next day. But Y classification, that's going to be a 1 if the price is increased, or a 0 otherwise. The way that we can refer to this is we take this value here, we divide this value for every row in the column, and if that value is greater than 1, the price has increased. If it's less than 1 or equal to 1, then the price has decreased or stayed the same. Let's call that column Y classification. And firstly, let's just do the price change, which is equal to the Y regression column divided by x2, or whatever the final column is for the specific sequence length. So we go Y regression, and we divide by the column before that one, which is not always going to be x2. It's going to be x, what is it, x sequence length minus 1. Because if sequence length is 3, that's 2, that's x2, and it works for the other cases as well. If we print this out now, I'm gonna I ran it again. What I'm gonna do actually is I'm gonna use the TQDM there. I'm going to wrap it around here, and this is just going to show me the progress of it. I'll use that in the future. I don't need it anymore, actually. Anyways, so we've created the column for DF sequential. And yeah, we've got the Y classification column here. Now, like I said, all the values that are less than 1, we're going to label 0 or equal to 1. And all the values that are greater than 1, for example, this one where the price has increased from 1.05 to 1.16, we're going to set that equal to 1. And the way we do that is we can just do a Boolean. We take this value and we write greater than 1. And if we run it again, it will put false and true. And all we have to do is just convert that to an integer where true is 1 and false is 0 by writing as type. And you can see that's all we need to do for that one. For example, we've got a 0 here because 251 is greater than 249, so the price has decreased, and a 1 here because the price has increased. That is the inefficient case, and I'll just show you roughly how long it takes. using the progress bar. Can I select all? Can select all. So there's a progress of it, and you can see it takes, I don't know, it'll take probably like 15 seconds or something, 10 seconds. You can imagine that if you have a huge data set, this will really add up. Although I do understand that if you're pre-processing the data, you'd only have to do this once. So it's not a huge deal if you do it this way. And this way is probably more intuitive anyways. But I'm going to go over the second way here. Let me demonstrate the structure for the second way. Okay, what we're going to do is just ignore the Y classification column for now. We're going to create that as we did before, so it's not a big deal. We're going to create these first 4 columns. We're going to do this for the 3 sequence length example case, and then we're going to generalize it. Just because it's a little bit more, less intuitive than the other way, but stick with me here and I'll show you how to do it. If we consider the starting and the ending point of each of these columns. So these columns depend on closed values. This column here starts at 1.59 and it goes up to some value, to some index in closed values. X1 on the other hand starts from this value here, which is the same as this value indexed up by 1. And it ends at this value here, and this is the same as this value indexed up by 1. The indices all increase by 1 with every column that goes along. In that method we can use a for loop, but we'll only have to loop over however many sequences there are, because we add a 1 to each of these indices here, and then we can slice the original array. And then all we need to do, once we have these 4 columns, is just combine them together into one big array, and then we can put it into Pandas data frame directly. When we create the Pandas data frame, we'll be putting in the values directly instead of just putting in the columns. I'll show you what I mean. This first column here, x0, let's create a list of the columns. So the list of, I don't know, list of slices. And each element in the list is going to be an array equivalent to these columns. I'm going to combine them. I'll just write this here now. Combined slices. And we're going to combine them with NumPy vstack. And we're just going to stack them together and it's going to combine them. And then we're going to put it into the data frame like this. df2 is... And then columns will be the same as this. Like that. Now we will have to slightly edit combined slices. We're going to actually have to transpose it before we put it in, and I'll show you why, but just disregard that for now. This is the general structure of the efficient way. I'll show you how we put the elements here into list slices. Now again, they're going to be slices of the closed values array. You can see the closed values array up here. This first column here is going to start at the 0th element. We can take the 0th element and we're going to go up to some value here. Now, because if we look up here to the for loop, because I goes from 0 through the length of the df minus sequence length, and I is equivalent to index start, the first value in each row is going to be equivalent to closed values indexed at I. Essentially, this first column is going to be whatever I is, whatever closed value is at the value I, at the index I. Therefore, closed values is going to, this first element here is going to be going from 0 through the length df minus sequence length. It's going to be the same as I. That's what we're going to write here. And now that we've got the first column here, we're just going to add 1 to each of the rest of them, because this column here is just going to be 1 index after this one. And this column here is just going to be 1 index after this one. We can write that here. So 1 length df minus sequence length, and then we just add 1. I'm going to write the rest of it here because it follows the same pattern. And now this is just, for example, 3 sequence length. It's just for the 3 sequence length example, but you can see that you'll see that we can generalize this for all cases. Wait, hang on. So this is +1, this is +2, this is +3, but sequence length is 3, so that's just length of the df. And you can imagine why, because this last column here, y regression, just goes to the very end of the data frame. All right. Now what we're going to do is just generalize it for all cases here. We have list slices, so let's create another one here. And this one's going to be generalized because we don't want to have to write out each individual column. Now, what we'll specify here is, this will be the format. So it's going to be a slice for I in range and then some range here. Now the slice is going to begin at 0 and it's going to go up to 3, which is sequence length. So we can specify I here for the first, for the index start here, and it's going to range from 0 up to sequence length. But hang on, so we've got 0, 1, 2, 3, so it's going to be sequence length +1 because it doesn't include the ending index. So that's what I is going to range, that's what the starting index is going to range. Now we need to specify the ending index, which it starts at length df minus sequence length plus I, because I is 0 here, so for the first case I is 0, so that's why we can write plus I here. But you can see that here's 0, here's 1, here's 2, and then we're just adding whatever value that is. So here we're adding 1, here we're adding 2, here we're adding 3, and that's why sequence length and the value cancel out. And that's the entire generalized case. Like, you can look at it more closely if you're a bit confused as to why it works. But essentially well, this for loop here, it's looping over all the rows. So the for loop is going to run some amount of times, 3,300 times, I think. But it's going to run the amount of times as we're creating the rows. This for loop here instead runs 4 times because it's looping over the columns. So it's looping 4 times. This one's looping 3,300 times. That's why this way is much more efficient. We're instead slicing each column instead of slicing each row. Anyways, that is the generalized case. And I think that's generalized for all of them. Like, we don't have sequence length 3 written anywhere here. Yeah, so this first one creates all the columns, then we're combining them together. All right, if we take a look at one of the elements in the list, let's take a look at the first column. You can see that it goes horizontally. So it's 1 by however many elements there are. What we want is we want to create a 3,290 or 3,300 row, and we want to create 4 columns. If we combine these together vertically, it's going to create 4 rows and 3,300 columns. I'll combine it vertically and I'll show you. If we look at combined slices, it's going to create 4 rows and 3,300 columns. It's going to, if we create a data frame with that, it's going to put it in the same format. But it's not going to work in this case because we've specified that we have 4 columns. If we put it in, we get an incomplete input. What did I write? Yeah, there we go. All right, so we see, yeah, so shape of pass values is 4 by 3,300, indices imply 4 by 4. Well, essentially, indices imply that there's 4 columns, but we've passed 3,300 columns. That's why we need to take the transpose of it. And that flips the columns and the rows around. And then if we take a look at combined slices, it's flipped around. So now we have 4 columns and 3,300 rows. Now if we put it in, it works. So we have df sequential here, and we have df2 here. We'll test to see if it's equal using a pandas function, but we're just going to create the Y classification column, and we can create it in the same way here, so we can just copy this over and let's just replace everything here with df2. Alright, now we have Y classification. We're going to compare the two data frames, and we can do that with the dot equals function here, and we just pass in the two data frames here, and essentially it's just asking are the two data frames equivalent, and it says true, so they are. That is how to create it for a more efficient case. See if we run this. Let's just get rid of everything else so that we can look at it a bit more cleaner. If we run this, just note that it takes about 10 seconds maybe. And this one, it's instant. That is why, well, that shows that it's more efficient. Now I'm gonna show you what it looks like for a high sequence length, and because we've generalized it, it'll work the same way. Just wait for this to run. And let's take a look at df2, for example. And there you go, you can see that it works for any sequence length. This is a sequence length of 8, and if we take the first, I don't know, 15 values, closed values, 1.59, 1.59, 1.58, 1.58, and so on. And you can take a look at these values closer if you don't believe me, but yeah, they work the same way. Anyways, that is how to create sequential data.